Hello guys, welcome to Maths and Physics Catalyst channel. If you are here for the first time, please subscribe my channel, like, share it to colleagues, comment with problems, questions, so that others will benefit also. So, this is our second lecture under functions, and today we are going to study algebra of a function, sum of algebra of a function. So we are going to cover odd and even functions, the inverse of a function, and the evaluation of a function. Okay, let us begin with odd and even functions. Odd and even functions. What are odds and even functions? So now, let us take us back to remember what are even and odd numbers. Okay? So even numbers, remember, are just numbers that whenever you divide them by 2, the result is a whole number, like 2, 4, 6, 8, and the rest. These are the even numbers. While odd numbers are those numbers in which whenever you divide them into 2 equal parts, you will have a decimal point. Or in other words, we can say they cannot be divided into 2 equal parts without remainder, like 1, 3, 5, 7, and the rest. This is what we know about natural even and odd numbers. So now, what does this even numbers do whenever we have them as power? We have to remember this. Let's see, power is something like this: x raised to the power of n. That is power. So when n is element of this even, or when n is among this odd, what happens? Let us take example. For example, we now said if this is a function f of x, for example, and this f of x function is equals to x power n. So we'll just take this function and try it when the power are what even, and when the powers are what odd, for a negative and positive input. So let me start with this. Let me start with the values of x to be, let's say, 1, 2, and 3, and minus 1, minus 2, and minus 3. Let us use this. Okay, let's say when the function f of 1, when the function is 1, what happened? And then the power is even. I will take this one. When it is even, I will take 2. For example, I have 1 raised to the power of 2, and the answer will be 1. When the function is 2, f of 2, I will take the next even number and see whether the same thing will happen. This one is what? It is positive. Okay, so I have 2 raised to the power of what? 4, and it will be what? It will be 16, which means it is also what? A positive number. So now I will now go and check these negative numbers and see f of minus 1. F of minus 1, when minus 1 raised to the power of what? Raised to the power of 2. Remember, the power 2 here is what? Is even. What happened? What is minus 1 power 2? It's like whenever you have x power 2, remember, it's nothing but x times x. So this is minus 1 times minus 1. And minus times minus is plus, which means I will have 1 as answer. Okay, now f of minus 2. Going to this one. F of minus 2, I have minus 2 power. Let me just take the next even number, which is 4. What happened here? I'm saying minus 2 times minus 2 times minus 2 times minus 2. And this will be equals to minus times minus is plus, minus times minus is also plus, plus times plus is also plus, which means I will just have 2 times 2 times 2 times 2, which will give me 16 also. So what's our conclusion? Our conclusion is whenever n is from what? From even numbers. Let's say example, when the power is 2 and 4, what happens? F of x always, whether you insert positive numbers or you insert negative numbers, become positive. It will become what? It will become positive. And now, again, if we do the same for odd numbers, let us go and do that for odd numbers. When n is from odd numbers, what happens? Let's say my f of 1 is equals to 1 raised to the power of, so I will start taking the odd numbers. That is 1. 1 raised to the power of 1. 1 raised to the power of 1 is 1. Okay. Now, in my next example, I will take f of 2. Remember, I'm using 1 and 2 equals to 2 raised to the power of 2 raised to the power of, what's the next odd number is 3. So I now say 2 raised to the power of 3. And 2 raised to the power of 3 is 2 times 2 times 2, which means it's equals to what? It's equals to 8. Can we say this? So the function is what? Is positive here. The function also is positive here. Can we say this? Okay, now let us check when the numbers x are negative. The same thing with this. Okay, when we try f of minus 1, what happened with f of minus 1? F of minus 1 will become minus 1 raised to the power of 1. And minus 1 raised to the power of 1 is nothing but minus 1. And which means we have a negative number. Okay, now let us try f of minus 2. F of minus 2, when the power is 3, we have minus 2 raised to the power of 3. And what is minus 2 power 3? It is minus 2 times minus 2 times minus 2. Which means minus times minus is plus, and we have to multiply this plus with another minus here. And we know that plus times minus is minus. Which means I will have 2 times 2 times minus 2. And which is what? 2 times 2 is 4. 4 times minus 2 is minus 8, which means a negative result. So, in conclusion, here is when the power is even, when our power is even, like here 2 or 4, if we change the sign of the input from positives to negative, it will not affect our result. That is, when they are positive, it gives us 1 and 16. When they are positive here, it gives us what? 1 and when they are negative here, they give us what? 1 and 16 also. We have 1 and 16. Similarly, okay. While when the function, the power of the function n is odd, from odd numbers like 1 and 3, 1 and 3 in this case, what happens? Once the sign is inverted from positive to negative, it produces what? Negative of the previous result. Like in this case, here it produces 1, while here it is what? Minus 1. Here it produces 8, while here it produces what? Minus 8. Do we understand? So from this one, we can generate the meaning of what is meant by even and odd functions. Even functions are just functions which turns the negative inputs into positive input. That is, they are positive inputs, and when you have negative inputs are the same. Okay? That is, even functions are just when the input of the function x, can you see that here it is x, is the same as when the sign of the input is inverted, like minus x. This is where we have even function. Like here, when I put f of 1 is the same as f of minus 1. When I put f of 2 is 16. When I put f of minus 2 is still what? 16. This means f of x is the same as f of minus x. In what? In even functions. I hope we are getting what I'm saying. This is about the even functions. Now for the odd functions, what did we observe? Odd functions odd functions, what happens for odd functions? When we put f of x and f of minus x, there is of course relationship between them. For example, when it is f of positive numbers like x and f of negative of the inputs like this minus x, can we see that the output here, the same thing will now become here but negative. The sign will be inverted. So in this, we can just say f of minus x, f of x equals to minus f of minus x. Or we can say f of minus x is equals to minus f of x. Each one we use is correct, is the same. Because once you take this minus on this side, it's still the same thing. So this is about odd function. Whenever you insert negative number in odd function, it will process it and put out the negative outside. That is the function of what? Odd functions. While these ones are what? The even functions. So as example, this function f of x is equals to x squared, and this function, let's say f of x is equals to x raised to the power of 3. This one is example of even and odd function. As you can see, the power is even, so it will be even function. This one, it will be what? Odd function. This is the one we use here, similar to one we use here. When we try, just if you want to try, let's say you want to check for the first one, we just say solution. We want to now know whether f of x equals to xy is even or odd. So this is the condition we need. If f of x becomes the same thing as f of minus x, we are fine. We are at home. It is what? It is even function. So for example, I will just try. Okay, what is f of x? F of x, this will be the general. F of x is equals to what? X squared. Okay? So now, what is let me do it in other way so that you're not confused. Let's say to represent the value in general, to represent the value, we can just say let x be equals to a certain value a. Okay, now start. Find the value of f of x. F of x, this is the function, x raised to the power of 2. So this means if we are going to find, we now let x to be a, this means we are going to find f of a. Is that not? And it will be what? It will be a square. Do we understand? So now let us go and say, now we keep this one. When x is equals to minus a, what happened? When x equals to minus a, we can say f of minus a instead of x, and it will be what? Minus a all square, and square will go with the negative sign.
F of x equals to x square, and we want to find what is f of minus a. So f of minus a will be minus a all square, and which will give us minus 1 square times a square, and minus 1 square is 1 times a square, which at the end it will give us a square. So from this we'll be able to understand that generally this function f of x squared is an even function. Okay, now when we have, let's say, f of x equals to x raised to the power of 3. So if we try f of a, it will just be a cube. Now when we try f of minus a, f of minus a will be minus a raised to the power of 3, and which can be simplified as minus 1 raised to the power of 3 times a raised to the power of 3, and is equals to minus 1 raised to the power of 3 is minus 1 times a raised to the power of 3 is a power 3, and at the end it will be minus a raised to the power of 3. So which means f of a is equals to a power 3, while f of minus a is equals to minus a raised to the power of 3. As we can see, the minus come out, therefore the function follows the rule of odd functions, which is minus f of minus a. Therefore f of x equals to x raised to the power of 3 is an odd function. Yes, and it is not only polynomial functions. In polynomial functions that we can have even or odd functions. We have the functions under trigonometric functions. So under trigonometric functions, whenever f of x equals to sine x or f of x equals to tan x, these two functions are what? They are odd functions. These two, the sine and the cos. While if f of x is equals to cos x, this one is an even function. The reason why we say that is first of all, whenever you input a positive number in cos, let's say you want to evaluate f of 30 degree first. F of 30 degree will be cos of when f of x equals to cos x, then f of 30 degree will be equals to cos 30 degrees, and it will be the same as square root of 3 over 2, which is 0.866. So now if we try f of minus 30 degrees, f of minus 30 degrees will be cos of minus 30 degrees, and now cos of minus 30 degrees will be the same as cos of 30 degrees, because let me just use if you use your calculator, you press cos of minus 30 degrees, you will still have square root of 3 over 2. So what's the meaning of this? The meaning of this is when you press cos of 30 degrees, the answer you get is the same as when you press cos of minus 30 degrees, which means f of theta or 30 degrees equals to f of minus 30. That's why we call it what? An even function. And now if we take another example for sine, when it is sine function, you try to put sine 30 degrees, and sine 30 degrees will be 1 over 2. So now if we embed the sine in, we now try sine of minus 30 degrees. Sine of minus 30 degrees will be minus 1 over 2. What's the meaning of this? The meaning of this is sine of minus 30 degrees is equals to minus sine of 30 degrees. Do we understand? Which means whenever you input a negative number, it will just take the negative outside, which is similar to f of minus x equals to minus f of x, and that is why we call it what? Odd function. So by the agreement that sine and cos, sine is odd and cos is even, if you can remember, tan of x of angle is nothing but sine of that angle over cos of that angle, which means whenever we have tan of minus x, it will just be sine of minus x over cos of minus x, because whatever is here must be the same as what will be here. So now what we'll do next is to simplify this. Sine of minus x. Sine is odd function as we agree, so therefore it will be minus sine x over cos of minus x. Cos is an even function, so therefore it will eliminate the negative sign and it will just be cos x. And as we can see, therefore tan of minus x is equals to minus this one. So now minus sine x over cos x. From this equation 1 up, we see that sine x over cos x is tan x, so I'll just say tan x. And this one also is the same as f of minus x equals to minus f of x, for f of x taking value of what? For f of x taking value of tan x. So this means tan also is an odd function. So this is about the functions.